All right. So Spark Declarative Pipelines, or SDPs, I think they're rebranded from DLT Pipelines, but that's kind of what I want to talk about. That's what I want to showcase and maybe give an example of how to use it and why, when, all that good stuff. So just a quick summary on SDPs, or Spark Declarative Pipelines, or DLT Pipelines, right? So all it is it's a framework right here for creating batch and streaming data pipelines in SQL and Python. So it's a way of kind of just ingesting the data a little bit quicker. You have a little bit more scalability factor, so that's kind of when you need it. So if you're ingesting a lot of data or streaming in a lot of data, this is when you would use that. So if you're familiar with Databricks, there are jobs and then there's pipelines. So jobs are pretty good. You can still ingest data or have ETLs in your jobs, and for the most part it does pretty good. But once you get to like ingesting like millions of rows daily, then you will probably need to lean on the SDPs to keep that scalability and not have to wait like hours, or I don't know how long it takes to run right now, but I remember when I was doing it, it would take me like hours to run not even like a couple million rows a day. And so with this, it allows me to do it within seconds. There is another key piece that's really important with SDPs that I find is one of the best use cases, is it's extremely easy to rebuild. And so that's what I'm going to lay out here, is how I'm going to rebuild it. I chose a really complicated one, in my opinion, just because it's just not so natural. It's not like these pipelines really don't want to deal with Excel files. So if you have to deal with Excel files, they're probably the worst case scenario for ingesting data. Their Excel files are basically zipped CSV files, and so you can't really stream it in without unpacking it. And so that prevents the streaming part, which is the whole thing for these Lakeflow SDPs, right? Is that they want to stream in the data. Another thing is I've used Scala to try to improve things. Now SDPs don't improve, aren't supported in these SDPs. So you can't use Scala to read in the Excels and do some memory management, which I've done with some async stuff to try to make it faster with the jobs. So you can still do that with jobs, just not with SDPs. So you really have to be a little creative. Now, I've leveraged Spark a lot just because it's really great for memory management. So PySpark is great, but again, I don't believe, at least the times I've been using it, you can't install Maven packages, which Excel is not, Maven package is not pre-installed on the clusters, so you'd have to install it. Now you can't do that on a pipeline, so what do you do? And that's what I'm going to kind of walk through, is like this crazy scenario, or this really tough scenario, which I think is very common, where you get just a bunch of Excel files and you just have to ingest them. So yeah, that's a little bit about the SDPs, a little bit like when to use it, like the use case that we're going to go through. Yeah, so let's jump into it. Okay, we'll probably come back to this change data capture. This is really, really neat, and I'll put a link to this somewhere. I don't know, but I'll put a link to it, and you can kind of go through it, but it does something extremely cool. I'll provide a quick summary, but basically, if you're familiar with Git and how Git works, where it's storing the changes, and so it can go back in time by just storing the changes rather than just snapshots of the files. At least that's how it works in my head, so I could be wrong, but here it works the same way, whereas you do a change data capture. So that's what the CDC stands for, and then as they mentioned, SQL Server, MySQL, and Oracle generate CDC feeds. Delta tables, they generate their own, which are the change data feeds here. So or CDF. So that's kind of what we're going to go based off of to make the ingesting of the data and building the tables a lot quicker. So we can use these to just to stream the data and then build these CDC flows. I call them CDC flows, but when building it out, it didn't mention it, but anyways, it's in the documentation to figure out how to apply these changes. There's different types, but I'll come back to that. Usually you could just use auto, but anyways, yeah, I'll come back to that. All right, so jumping into the project. Okay, so here's the project that I built out. So I created my scenario where I'm generating these purchase orders. So we're just getting a bunch of purchase orders. And then some things that do happen is a lot of times you get snapshots, like a rolling 30 days or like a report of these purchase orders that's like a rolling 30 days, week to date, quarter, year, right? And so you get them all and you have to adjust it in, but you don't want a table that has like redundant or duplicate rows, right? And sometimes those purchase orders were like when they generated the file or report, there was a mistake and then they updated it, and there's just a lot of issues that kind of come in. So you always want to take the latest one for the most part. There are some scenarios where, like, for instance, if you get a rolling portion of it, you may miss line items for the purchase orders, and so you may want to maintain those in the prior, but you have to operate under certain assumptions. But anyways, you can build that use case out however you want, but this is just the use case that I just built out. Now I built it super quick, so it's not a great one. So basically it just generates a bunch of random purchase orders and then throws them in Excel. So how that works is, I'll click on one of these runs, and here we go. So I like Polars a lot, so I think it's better than Spark in some cases, but I think it's easier to use. So Spark is great. Polars is pretty solid. I recommend it. Basically, you're just generating, here's like a little template for what it uses to your vendors and catalog, anything for the purchase order. So it's doing that. It's going in, just picking a bunch of random stuff going on here. And then it assembles it. And then I just try to randomize it a little bit. And then this one, in this, there should be 361,218 rows. So that's how many rows are going to be in this Excel file. So then right here, I write it to a volume, which is a cloud storage for me. So we just create an external volume to the cloud, our cloud storage. And then we just save that as an Excel file just for now. Throw in some sort of template, hopefully again some sort of template for an Excel file. Hopefully they're putting like a file date or like an email date time, or I try to do email or not email, sorry, date times, because sometimes what will happen is if there's a mistake in the report, they'll send it later in the day, and so you don't want to replace that same file date because you may need it later for auditing purposes. So you would you need to try to use date times whenever you can. I think most cases people say use date, and I get that, but I would try to use date time as best you can. So anyway, so we write that in there. That runs. We can see over here, it's on schedule for every 30 minutes. So every 30 minutes it just generates another one, and there's a lot. Okay, not too many, but there's a good amount. So probably a couple million. And then, so with the pipeline, what I like to do is I like to have it all in one place. Now, because they're Excel files and they can't be streamed, you have to put it in a format that is streamable. When trying to do this in the pipeline, what I would do here, so I'll just open it up so you can see, and I'll show you. So what we do is, now notice this is on file arrival, and this is connected to the on the last one, that one that generates, that sends it to this raw folder or directory, and throws it in staging. What this is going to look is to see if a file has arrived. It's going to wait a certain period of time just in case more files are coming in, and so it waits until the last file change for like a minute or so, and then it begins this this flow. So we go here, it pulls this, and then now it uses this. Now pipelines don't like this. I don't know why, but they don't like it. And so if you're going to use this method, what's it called? Yeah, if you're going to use this method, then you probably want to separate out. And it's kind of a good idea as well, because there's a lot of complications that kind of happen here. It's kind of good to have them separated, like your streaming pipeline and your job that's kind of breaking apart the Excel and storing it in a format that you want, that you can stream. That could be a CSV, JSON. I'm going to use Delta tables just because I really like Delta tables. So I think it's a great format to just start storing your data automatically. Parquets, feather files, pickle files, all this stuff is I don't know if you can stream feather or pickle files, but I know you can stream parquets. So, but yeah, something to look into. Okay, so now you can use the OS package to do this, and you won't run into that issue, but I was running into issues later where, see, I'm moving it, and I'm like, you know what, at this point, I should just store it in a separate job. It's probably a better practice anyways. So anyways, we just kind of go through some async stuff in there, and all we're doing is, okay, so we're raw Excel to bronze delta. So we're just grabbing that file date time, creating the bronze file name, reading the Excel, creating the data frame, and writing it, and then moving the file from staging to process for the raw file path. Now, I'm going to do the same thing for silver, and the way I normally would do this is, okay, so the reason why is in this pretend scenario, you know, you have your raw files that are coming in, and then you go throw it into bronze. And I use this medallion system, which you can look up, and maybe I'll put a link below or attach it to another video where I kind of go through the medallion system. But basically, we're going to take the raw files, ingest that into bronze, and then bronze into silver. So what I do for raw to bronze is I take just the file format, and I'm putting it in bronze in a file format that, or data format that I want to use. So in this case, a delta table, right? And so from there, but nothing is changing. All the data types, all that stuff, assume that to be true. Now, normally what I'll do, because reading these Excel files, going to pandas is not the worst, but it's really bad. So especially when you need to preserve data types, pandas will a lot of times move every data types to object data types, which is why I really like polars, which is also why I really like Spark, is they maintain the data types. They find it really important. It is important because you don't want to mess up your schemas when you're ingesting data. It's one of the most important pieces. So normally what I'll do is up above, I'll classify ingestion schema, and then I'll throw that in here when creating the data frame. So making sure that the data we're getting matches the schema that we want to ingest to, and any so stuff like that. Then in silver, if I need to like convert data types, if I need to add columns, which you can see here, I'm adding a file date column, which should have been a file date time, but I was just moving through this pretty quick. So yeah, then that's when I would do that to silver. So silver becomes the manipulation. So raw to bronze is just converting it into the data types, or not the data types, the file format or data format that I want, right? So in this case, it's delta table. And delta tables aren't files; they're more like directories of parquets with a little bit of logging that goes in, so you can collect version history and all that sort of stuff. So they're like parquets, but they have an extra layer that's really awesome for version control. Yeah, you can version control your data with delta tables, so you can go back in time and look at a snapshot. So it's super cool. But anyways, so yeah, so silver, we're just going to go ahead and do some manipulation. So let's say we're going to convert a string of dates to a date time, or add a column here, and then save that to silver. So that's kind of the mimicking that I'm doing here. And now, why can't this be done in the pipeline? Why is it done here in the job? So here is what I would normally do, is I would put the file date, so here, so I don't like this redundancy, I'm really against that, but what I would do is I would store this as part of the metadata of the file. So store that in the metadata. What this will allow is us to be able to easily rebuild off of bronze without, like, if I make a manipulation to bronze, to rebuild off those Excel files is going to take an extremely long amount of time. So if I only have to rebuild off bronze, then I'm doing great. So I can store now the reason why I don't like this redundancy is for a couple reasons, but it's okay in this scenario, is I would take, once I have my way of extracting the file date time from the file or the data of some sort or whatever metadata of the source, something like that, right? I would store that in the metadata of the table or of the file. And then I would pull that out later using like a metadata extractor. Now I didn't want to write the code for that because just you can use your imagination on how to do that, and you can look it up, all that sort of stuff. If you want, I guess I could do that too later on. I could just add to this and simulate that, but I think it's a lot better to have it in the metadata. We have to be careful with the way you manage it, because if you move the files or delete the files, you lose that metadata. And so again, you want to make it in a way that you can easily rebuild. So for instance, why would you want to rebuild? Okay, well, let's say your data type is actually, you find out is actually pretty bad, or like, hey, there's a new column coming in and it's causing some issues, or something like in your calculation is wrong in Silver. So you're doing an aggregation, the aggregation's wrong. Imagine you had to rebuild that on all the Excel files. That would be excruciatingly painful, because you have to unzip them all and process this whole async method. Now with here, you should be able to move those files, or yeah, so here what this is doing is it's taking the results from bronze. So as you can see here, so we get results. So it's taking the results from bronze and then reprocessing them. So what you could do is just easily go in here, add a cell that then grabs all the bronze files and then reprocesses them. So that async method should work like, I don't know, 100 times faster. I don't even think that's an exaggeration. I mean, it depends on how many you have, but it could go from like days to weeks down to of processing those Excel files down to like minutes to a day maybe. So you get a lot of speed out of just processing the delta tables over reprocessing the Excels. Sorry, that was a bit long explanation, but that is the reason. Okay, so that's the ingestion from bronze to silver. Notice these are just being stored back into separate silver delta tables. So these are just, they're not like one whole delta table, it's just individual delta tables. So then that's the next part we gotta fix. So that's where the pipeline comes in. So we go here, boom, we have a dev prod pipeline. The dev one, this one you can run manually, and this one gets triggered off these two jobs. So they're kind of made in tandem. I wish this one would have an underscore prod at the end. This one would have an underscore dev. How do I know? Well, the prod one, based on the configuration that I set up, is set to the run on file arrival, whereas this one is not. So this one you have to trigger manually, which is good because that's what you should do for dev. But yeah, so what we'll do is we have a streaming table, another streaming table, and a materialized view. So 27 million. Okay, that's a lot of records. I'm assuming that's the bronze one. Let's see. I won't waste time on that, but I probably, if I hover, yep, okay, so dev procurement bronze purchase orders. So yeah, that's the bronze one. Then you have your silver, and then from there you go into your golds. So this will go from silver into these two gold tables, and I have these two to kind of show an example of like the little bit of a difference that we have here. Now notice, to then stream those tables, you can see a duration of 53 and 46 seconds, and then to build these last two gold tables, these are the two gold tables, and then this last one is the silver one probably. But you can see that this is, by the way, a full refresh. So completely rebuilding from those silver and bronze tables. Well, really the silver ones. I keep the bronze ones there just because for auditing purposes, like if you get a request that like something's not right, instead of like going to the delta tables and querying them in a notebook or something like that, or, I mean, I know you can query it from a SQL query, but it's nice to have a table that you can allow your team to go and access those bronze ones and really pick out the specific file that there was an issue on, and then we can track that down a little bit quicker. So that's why I have the bronze one, silver one, instead of just purely the gold ones. So yeah, let's see. Okay, so it's super quick. I mean, within a couple minutes, so duration time is literally a couple minutes. So we have starts at 2:10 and then ends at 2:12. So, I mean, super quick. So that's the great part, is it's rebuilding. And this is millions of rows, right? So this isn't like a couple thousand. I mean, I'm going to keep pushing the limit. So I'm just going to let this thing keep running and generating for a couple of days and see how long it takes to refresh on. But okay, so what do these look like? All right. Oh, one thing I do want to show is a quick difference to prod, which prod is looking like it's running right now. So we'll wait for that to complete as well. But notice there's only the purchase orders one. There's not that LC one. And I'll explain why. And I kind of wanted to show how quick it is to make an update to your pipeline, run it, and then get moving on and I don't know, publishing your reports and stuff. I don't know, whatever you want to do. But this is what they look like. So here's that streaming of the bronze and silver. I'll go ahead and minimize this. So you're in your pipelines, and I probably will make a video on how to create one, but I just want to show really the effectiveness of the pipelines. So here we go, create or refresh streaming table. So you have the bronze, and then you can see that this is streaming from the volume. Oops, I can't. There we go. So streaming from that volume. And then the same thing here. This one is streaming from the silver. And this is showing that you can do it from a bucket, and then this one's from a volume. This is an external volume, so kind of the same thing as this Google Storage bucket. So you can stream from these locations. So that's all it's doing. It's just reading from the Delta table directory that I have, and then it's building the table from there. So it's just literally concatenating them all together into a single table. So it's going to be huge. Then what we're going to do is consolidate that into this gold. So I created two. This is the purchase orders ones that you saw in prod and in dev. But basically all it's doing is it's creating the applied changes into. This goes back to the change data capture. It's super cool. Okay, so let's say, so January 1st, January 2nd, you have Chris's owner, Chris's manager, and then the change data feed is just Chris's manager update, right? So it's storing that data feed and then building the tables off of that and keeping the historical changes. So we have two types. We have type 1 and type 2. So what it's going to do is keep only the latest data, pretty simple. So we have Chris manager, and then the second data type is Chris owner and Chris manager. So it's keeping both, and the historical. I don't really see a big use case for myself on type 2 at the moment, but so I normally just do the type 1. But I think a big recommendation that they state is to let it do auto, but I mean, I just really wanted to make sure I got the type 1, so I specified that. Yeah, so I specified that. So that's all we're doing, is we're just creating a CDC flow, and yeah, and basically here are the keys is the purchase order number and the line item number, and then sequence by file date. So this will look, when the latest file date comes in, it'll go through and create a merge or an upsert with these two keys, which is super, super cool. Now this one is just taking the, which isn't quite, the reason why we're not doing a CDC here is because it doesn't quite work that way for CDC. So as you can see, it does the change. And so what it's doing is it's focusing on the, this one focuses on the row. So if your purchase order and line number are not being changed in the latest file date, or are missing in the latest file, then that will not get changed. It'll remain there, and I'll showcase that as well. Whereas this one, what it's going to do is it's going to partition by the purchase order number and then see the file date. So it's going to basically take those snapshots, and then it's going to take the latest file and then replace all the purchase order numbers with that latest file. So if you have like different line numbers in the different files, it's only like say you had 3 on day 1 and then 2 on day 2, then this one will replace those 3 with just the 2. So it's going to ignore that third one. Whereas this one will keep that third one, and it'll just have a different file date and structure there. So, all right, now what does that look like? So going into this final piece, which actually I kind of want to showcase this target. So this is dev, and then I haven't pushed it to prod yet, just because I want to showcase that like how quick it is to do that. So if we go here, I have these 3 at the bottom, and it's kind of a quick case where I was just kind of looking at like if there was a purchase order number that's repeated a bunch of times, which that's what this query did up here, where I counted the line numbers, and it was like it repeated a bunch of times. Okay, so it should be upserted. So what does that look like? So right here, so we'll do silver. This will be from prod, and we'll look at that purchase order number. So there should be a bunch of them, like I don't know, hundreds to thousands of just this purchase order number in theory. So we're going to read this query, and it has to start the warehouse, so that's what's taking a little bit longer. So about 8 seconds. I'm not too happy with that, but not too bad. But as you can see, a lot of repeats, and this is so 195, so not thousands but hundreds, right? So for that purchase order number. Now if we go down here and we do that prod procurement one for that purchase order number, and we run that, we see minimization. So that's the purpose of the CDC. So that's what that one does there. Let me check on that line number. That doesn't look right, but I'll look at that in a second. Let's see what the dev one looks like. Oh, that's the LC one. We just want the first one. Okay, so as you can see, the line numbers are 1, 3, 2, 6, 4, 5. Now the things I want you to note here are the file dates. So this one is, they're all 220, but this one's at the time of 10. This one's 9. Are they all 9? Oh, okay, cool. So then just that one. What's the difference here? Okay, cool. So what I wanted to note here is this this date here. So technically on this file that we received, there was really only this purchase order number. So for some reason, we can pretend in this scenario that these were all mistakes. And so since these were all mistakes, we really only want this one, right? Let's just assume that. So when we run this LC one, we can see that this is the only one that comes back, because that's the only line number that existed in that file. So we only accept that one. Now that may not always be the case, so that's where the CDC comes in, and that's the use case, right? So we're keeping those, but we're keeping all these line items. And so when we need to maintain that and really just update and based off of the changes that happen and not necessarily replace everything, that's when I would use this CDC flow. So that's that one. And if we go here to boom, and I'll look into the this one right now. Now if we try to run this one, it should break because it doesn't exist. Why doesn't it exist? It's because it's not existent in that it's not pushed here yet. So we're just going to go ahead and deploy it. Okay, so finish deploying. We'll go back here to prod and to show how quick it is. Okay, so this is something super cool. So notice the output records here is 412, 412. And I'd go back further, but let's go to the dev one. How this one was 27 million, 18 million. So this is pulling everything from the sources because that's why it's a full refresh, right? And this one is just a refresh. So it feels similar, but it's not. So it's completely refreshing the data sources and the stream. So all those change logs are just being erased, and we're just repulling everything. So it's only pulling the little bit of stuff, and you can see upserted is only 118K rather than the millions that we saw. So, or I think this one was only a couple 100,000 more, or like 800,000 or something like that. But anyways, we'll see right now. But yeah, so that's also the benefit. So notice, like, I'm not specifying what files to stream in. It knows what files to stream in and which data to stream in. So that's what's also making it super efficient. So while this one will take, like, let's say 2 minutes, which I'll probably fast forward here in a second, one thing I want to note is look how quick this is. So 11 seconds, 28 seconds, 13 seconds, right? So you're looking at probably a couple minutes to spin up. And once it spins up the serverless compute, then generating these tables is super quick. And we can look at that on the previous one too. So very quick. All right, back to these, send up the tables. I'll let it run, come back. All right, so it finished. Again, a couple minutes, pretty cool. So 28 million, 18 million records. Upserted 884,000, which is pretty cool. I mean, that's a big reduction there. But again, the biggest thing I want to point out is it's processing millions. We did a full refresh, so this is rebuilding from bronze or silver, if you want to say. I mean, silver was really no different than bronze in this case, right? So it was just really adding that column. I think this is lighter because I built the silver one later and I just didn't grab all that data, the backlog stuff, which I can do just, I'll probably do later, but it's just for an example where you're taking millions of rows from all those delta tables and you're just quickly compiling them into here by streaming them in. So anyways, yeah, let's see. Now I can show, probably next time I'll show rebuilding silver from those bronze tables to show how quick that is, because I think that's an element that's not being displayed here, right? We see how quickly within a minute or so that it's building those gold tables from the silver, which is pretty close to the bronze. But remember, we're using Python's async to build these, which is not going to be very fast, but it should be okay. It shouldn't take too long. I'd be very curious to see, especially when we're using serverless computes. It should be pretty quick and should maintain the memory pretty well as well. All right, so now we have these built. This is in prod, so we should be able to go back down here. I'm gonna refresh this. A little bit blinding there. Okay. So now we have here, we can run this, and there we go. So this is the latest change. Now this is going to be different than the dev one because this one updates every 30 minutes. This one updated the last time I ran it, so which was probably like an hour or so ago, or maybe an hour and a half ago. So that's why it hasn't taken those latest random changes random generations that I've taken in. So that's why it's taking this, and you can see right here 1031, 1031, whereas this one is 1001. So this is from 30 minutes later. Now, moment of truth for this golds one. All right, there we go. So yeah, it was just I had to push that update to prod, and then that's where we get these results. I think, okay, so I made a change where I was trying to mimic this materialized view with the CDC, and what I did is I removed this, which I think is why we saw those repeated line numbers. So I pushed it to dev, and then I guess I pushed it to prod as well, but adding this back in, then re-pushing that to prod, we got that all sorted out. So everything is looking good there. Let's see, so you know what, let's see if we can find something else, because these match up. Oh no, this is 1 2 3 4 5. It's 1 2 3 4 5 6. Oh, notice this one. See, that says 631. So that got me for a second. So not 1031, but 631. So since this one was a while ago, and so on the later files there has been no 6 line item, only 5 it looks like, and that's what we're seeing on these latest changes, is the 5 that came in on the latest report. So anyways, yeah, that is a SDP or a Spark Declarative Pipeline or DLT pipeline, which is a Delta live table pipeline. But anyways, I think SDP is the new convention. So that is it. That's how you build an SDP, a little bit, or an example of one. I'll probably show a later video on how to build this out. So yeah, some key takeaways from this is, just looking at my notes here. Okay. Some key takeaways is when you're using a pipeline, it's not the same as a job. You lose out a lot. You can't use Maven. You can't use Scala. You can't just read Excel files in the pipeline like you would in a job. So you lose out on a lot. Now, you still can use Python in a pipeline. I just prefer SQL to try to keep the pipeline as simple as possible, just to keep that speed and all that stuff. But you can use Python. You're just I feel like you're very limited on what you can build out in a pipeline. So all the like instincts you have with the job, once you have experience creating those Databricks jobs, you kind of lose a little bit of that functionalities in pipelines. So that's a key takeaway there. When to use it. So one, you would use it when you can stream data. So Excel files is not the great case, but we're building this scenario where you don't necessarily have streamable data and you're making it streamable. So you're putting it in a way where the pipeline is useful, right? Because like you can't just keep using the jobs to ingest those Excel files. If you tried to do it, you might be, it's just not quite optimized because you need the streaming and you need the CDC flows to really help you out, make it more efficient. I think the difference was on the ETL jobs, it would run for about like 40-45 minutes. It's switching to the streaming, you saw within a few seconds it's streaming that data in. I will do a benchmark to really compare the two, where I'm taking fundamentally the same idea and then putting it in a job and testing them out side by side. But you have to build probably just in Python, because you have to build out all that merging and stuff that's happening with the CDC flow. You have to build that entire functionality out in your job. So keep that in mind too. What else? All right, so what can we improve on? So that will be the next piece here. So what can we improve on? One thing I want to improve on is my pipeline. So this, when you normally go to edit a pipeline or create a pipeline, so you do like new ETL pipeline, I would select this option. Now I didn't, because I just wanted to quickly start out and just do it. But this one is sets up all that version controlling with the pipelines with the dev and prod for you. The only thing I don't like is it sets up a Git, a .git folder in there, or directory, which does the Git version control, where I like to control my own. So if I go to here, I go all files, pipeline example. This is actually my my ETL pipeline is in here, and then that's where all this is. So you're gonna see a lot of things that aren't gonna match, which I'll show you in a second. So when you build it out this way, it'll build all that functionality, the dev and prod, which is extremely useful, definitely needed. And then you could probably remove the .git folder manually, and then you can have your outer stuff in there, like documentation or like another job. So for instance, here in my files, here's my pipeline, and then here's that raw to bronze to silver job. So it's all in the same sort of pipeline GitHub repository. It's just broken down into a little bit differently. So that way I'm not having them completely separate. Again, not the end of the world, but that's kind of the way I like to organize it. So doing this setup as a source controlled project would have built out a lot of that functionality for me a lot quicker. And then there's one piece I want to show. So notice here you have all this red stuff, and that's because you're more editing the bundle rather than editing the pipeline. And I'll show you what that means here. So we'll open this up, go here, purchase orders, let's just go dev, edit pipeline. Now I'm just going to do proceed with edit. Notice a little bit of a different layout. You have dry run, you have run pipeline, you have run table refresh. You go here to your settings of your pipeline, edit the source folder, which you'll see this once you have this configured over here. So you have your default catalog, yada yada, a lot of stuff in here. Now I can edit this, but I don't want to, because this is again editing the pipeline that's in the bundle. If you don't know what the bundles are, you can read the documentation on the pipelines. It's just a way of packaging the pipelines into, like, I would assume more almost like GitHub jobs. It's like into prepared YAML files and statements such that Databricks can execute it a lot quicker, I think. So that's yeah, so you would, now if you did the source code way, you would have all that functionality. And I did have that functionality. It's just when I added this Databricks YAML, which this kind of sets up those targets for me. Me doing it manually, I think, messed it up a little bit. So that would be a different approach, which will, I think, offer you a better experience doing this. So yeah, that's kind of what it looks like. A little bit better. You can do dry runs, which is pretty good to kind of make sure that you're going to pass all your validation checks before you start pushing out those tables, because that kind of offers some complications. Like if you create a table that's a streaming table and you want to make it a view table or materialized view with the same name, their pipeline's gonna not like that, and you're gonna have to change that by dropping the table and then rerunning on a refresh. It's a bit messy, but yeah, that's it there. I will probably, what else can we improve on is doing the metadata and then doing the benchmarks to test the difference between them. But that is it. So yeah, thanks for watching. Appreciate it.